Hey y'all, in this video lesson, we're going to be exploring some very basic inverse trig functions. If you recall from one of my previous videos on the unit circle, we have the circle and we call this a unit circle, and then inside this circle is a triangle. And based on that triangle, we have all of our trig functions, and we used lots of things to kind of build that out, but one of the easiest things we used was called SOHCAHTOA. And we came up with these ratios. Well, we have these ratios that help us find the sine of the angle, cosine, tangent, cosecant, secant, cotangent, all of the trig functions from the SOHCAHTOA. So we can use inverse functions to find theta or any angle if we don't have the angle. So let's say we have the measure of the sides instead, and we're looking for theta, then we're going to use inverse functions. So basically here, we're just trying to solve for theta. So if we take the inverse of both sides, then they undo each other, and we're left with theta equals inverse sine of y over r. And that works for all of our trig functions. If you just take the inverse of both sides, now you have how you can solve for a missing angle. So I have a couple examples down here. We're going to round to one decimal place, so we're going to be getting an approximate solution. And we have a right triangle, so we can find this missing side here. But what we're actually looking for is the angle. So I don't even really need to worry about the missing side. Now, if I were solving the triangle, then that would mean I'm going to find that missing side and the other missing angle. But for right now, we're just going to focus on theta. So with theta, I have this right angle. And across from the right angle, I have the hypotenuse. And then in reference to theta, I have an adjacent side. And using SOHCAHTOA, I can figure out which trig function I need to use, given that I have adjacent and hypotenuse. So if I write out SOHCAHTOA, then that indicates it's going to be cosine. So I'm going to say the cosine of theta is adjacent over hypotenuse. But what I'm solving for is theta. So if I take the inverse of both sides, then I end up with theta equals inverse cosine of 12 over 17. Now, if you want an exact solution, you can just leave it like that. If we're doing an approximate solution, which we are because we're rounding to one decimal place, then we're going to pull up our calculator. We're going to make sure we're in degree mode, since we're talking about degrees. And then I'm going to go second sine 12 over 17. So theta is about 45.1. The 9 behind the 0 rounds that 1 or the 0 up. So that's how I got 45.1 degrees. And that's all you have to do for that. So for this next one, pause it and figure out which sides were given, and then figure out which trig function you would want to use to solve the problem. So in reference to theta, we are given the hypotenuse and opposite side because it is across the triangle. So that's opposite. And then the hypotenuse is across from the right angle, which means if we have opposite and hypotenuse, we're going to be using sine theta equals opposite over hypotenuse. Inverse both sides. This would be an exact solution. And then if we type that in, make sure you're in degree mode still. Second sine, there we go. 31 over 36 is about 59.4 degrees. And that's all. Okay, so moving on to the next example, I have here our unit circle. This is something that you should definitely be familiar with, but if it's something you're not, then you might consider having it handy as you work throughout the course. But I went ahead and just put it here for quick, easy reference. When you're given a ratio and a trig function, you can use inverse trig functions to find the angle that you're looking for using the unit circle. So in the previous examples, we had some values that weren't necessarily on our unit circle. And so these examples are going to be where you can easily find them. And keep in mind that there might be more than one answer for these. So just watch out for that. If you notice here, the interval goes from 0 is included, 2 pi is not. And the reason I did that is because 0 and 2 pi are kind of the same spot. So I just said, just include 0 and not 2 pi there. So if we're finding the inverse cosine of 0, then basically we're looking for all of the angles in radians where cosine is 0. Remember that cosine is associated with x. So I am focusing on the x values. So if I go through and I look at the x values, then I have a 0 right here and right here. That's the only two places. So the only angles where cosine is 0 is at pi over 2 and 3 pi over 2. So we get two solutions there for that one. And if you wanted to just take a quick note here for in case when you look back, where is the x value? 0. We found that to be two places. All right, for the next one, inverse tangent of negative square root 3. Now this is going to require a little bit more work because remember tangent is sine over cosine. So let's see, write that up here. Sine over cosine. So I'm looking at the y values over the x values, and where that equals negative root 3 is what I'm looking for. So this is just some simple algebra here, just a little division of fractions. No big deal. We can divide fractions at this point. So you're going to go up to your unit circle. And if we have, right now I can just focus on the positive quadrant and then I can use that to find my other answers. But if I were to take the y value, wrong tool, y value and divide it by the x value, that means I'm going to flip it and multiply. And we get 1 over square root 3. And then simplify. I'm going a little fast here because I've gone over this a little bit already. We get root 3 over 3. So it's not that one. I don't even have a root 3 right here, so I don't really need to focus on that by process of elimination. I know it's going to be this one, but I do want to show you algebraically how we get there. We take the y value and divide it by the x value, flip the second, and multiply, and we get that root 3 we're looking for. So we're focusing on the angles that have this coordinate point, but remember that in the original problem, it's a negative square root 3. So we need to figure out where we're going to get negative when we divide. So obviously this one is not negative, which means we're not going to use that. But if I go over to 1/2 comma root 3 over 2, right here, I have one negative. So negative over positive is negative. So this one's going to work. And then another one, nope, that's double negative right here. So I'm not going to use that one, which means my other one is right here. So I have two answers, 2 pi over 3 and 5 pi over 3. And that's all we're looking for. And if we kind of break this down a little bit, basically what's happening here is we're adding pi. So that could be a little shortcut there to find that second angle we're looking for. All right, last one, inverse sine of -1/2. Sine is associated with which coordinate, x or y? If you said y, then you are correct. So we're looking for where the y coordinate is -1/2. So we go up here and we can see that it's going to be down here. I need to highlight it. -1/2 at 7 pi over 6 and -1/2 at 11 pi over 6. So we get two answers. And that's it. That's all you have to do. So again, I would get very familiar with the unit circle if you're not already, so that you can do that a lot faster. Knowing where the functions are positive and negative, using that all students take calculus memory device, and being familiar with all the angles, this will be much faster. One more thing I want to go over for this lesson is sometimes, depending on your textbook or homework question, you might see this instead, the word arc in front of the function. So arc sine, arc cosine, arc tangent. That's just another way of writing inverse of the trig function. So when you see that, don't panic. It means the same thing. So that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.